This year has been a tough and challenging year. Having a balanced life has been a pretty difficult task to do due to multiple things to be accomplished. Being a son, a brother, a cousin, a grandson, a friend, a church organization member, an warrior, a student, and a person aiming to graduate as valedictorian this school year are tasks that I need to juggle despite the challenges this ODL has in stock for me. However, looking back to what I have accomplished makes my heart full. I have never imagined myself making short films, tutorial videos, posters, and such. I have managed to have a balanced life in spite of all the challenges I have to surpass.
As I learned to have a balanced life, I also learned about chemical equilibrium. Let us cap off the last cap of this school year and indulge with the principle of Le Chatelier.
Le Chatelier's principle is our topic today. What does it mean to us? And in chemistry, now let us indulge with this. Tackle all the stress, pressure and temperature, and concentration.
Le Chatelier's principle by a French chemist and engineer named Henri Louis Le Chatelier states that if a system at equilibrium is disturbed by an external stress, the position of equilibrium shifts. It shifts to counteract the stress applied or the change that happened. This has been one of the central concepts when it comes to chemical equilibrium. The stress pertained in there or the changes can be caused by the following. First, pressure. Second, concentration. And third, temperature. First, pressure. Pressure together with volume can have an impact of chemical equilibrium. Remember Boyle's law that pressure is inversely proportional to volume. As pressure decreases, volume increases. While volume decreases, pressure increases. Now we are knowledgeable that pressure has an inverse relationship to volume. Let us now proceed to pressure. But before that, I want you to remember these terminologies. Forward reaction is from the reactants to the product side, while reverse reaction is from the product side to the reactant side. Remember, when it comes to pressure and volume, we just need to look at the number of moles of either the reactant side or the product side. So if we increase the pressure, the equilibrium will shift at the side with fewer moles. However, if we decrease the pressure, the equilibrium will shift at the side with more moles. Again, increasing the pressure, fewer moles. Decreasing the pressure, more moles. However, in volume, decreasing the volume, the equilibrium will shift at the side with less moles. And increasing the volume will lead the equilibrium shifting at the side with more moles. See? They have an inverse relationship to one another. Look at this example. We can say that the reactant side has more moles compared to the product side. The reactant side has 1 plus 3 equals 4 moles, and the product side has only 2 moles. So if we increase the pressure, the equilibrium will shift at the fewer moles side, which is the product. And if we decrease the pressure, the equilibrium will shift at the side with more moles, which is at the reactant side. When it comes to volume, if we decrease the volume, the equilibrium will shift at the side with fewer moles, which is at the product side. And if we increase the volume, the equilibrium will shift at the side with more moles, which is at the reactant side. And that caps off the idea of pressure and volume. Let's now move on to another concept. Second, concentration. If we increase the concentration of the reactant side, forward reaction will be favored and the equilibrium will shift at the product side. The product side will use the excess substance from the reactant and make it as a product to achieve equilibrium again. However, if we increase the concentration of the product side, reverse reaction will be favored or speed up and the equilibrium will shift at the reactant side, so that the reactant can use the excess substance from the product side and transform it as a reactant. In that scenario, equilibrium will be restored. Look at this example. What if we add H2? If you answered that the equilibrium will shift at the product side, you are correct, since as we increase the concentration of the reactant side, forward reaction will be favored and the equilibrium will shift at the product side, so that forward reaction will speed up to use up the excess substance from the reactant side and turn it into products to restore chemical equilibrium. Lastly, temperature. But before we continue, I must introduce you to a concept called endothermic reaction and exothermic reaction. For easy understanding, I have here 2 pots. Imagine that we are in a stove. If I put heat or applied heat in the reactant side, that is an endothermic reaction. For in an endothermic reaction, heat is being absorbed. On the other hand, if I put heat in the product side, it is an exothermic reaction. For in an exothermic reaction, heat is being produced. Let us now continue in terms of Le Chatelier's principle. If heat is being applied in the reactant side, equilibrium will shift at the product side. In contrary, if heat is added in the product side, or if it is an exothermic reaction, the equilibrium will shift at the reactant side. Oh, by the way, endothermic and exothermic reaction can also be identified in the values of the change in enthalpy, or delta H. If it is negative, the heat is on the product side, therefore it is an exothermic reaction. If delta H is positive, it is an endothermic reaction and the heat is at the reactant side. Look at this example. The heat is present in the reactant side. Therefore, it is what? Endo or exo? Perfect! It is an endothermic reaction for the heat is present in the reactant side. Therefore, the equilibrium will shift at the product side. But what if we reverse it? What if heat is being added in the product side? What will it be? An exo or endo? That's right, you are correct. It is an exothermic reaction. Therefore, the equilibrium will shift at the reactant side. Now, it's your time to shine. Answer these following questions. And that's the end of our lesson, guys. I hope that you have learned a lot about Le Chatelier's principle or chemical equilibrium in general. But also I hope that you are inspired to have a balanced life despite the uncertainties, adversities, and challenges we are facing right now. I believe that one day we will wake up where face masks wouldn't be necessary at all. Face shields wouldn't be seen in anyone's face. And we can live our normal lives or even a better life. I am your teacher, vlogger, tutor, scientist, chemist at times, John Luis Quinto, now signing off. This will be the end of my chemistry tutorial videos, and I hope that you have learned a lot in this journey. Thank you very much.